Hi, I am Mali, and welcome to the channel. Stabality AI released its first model for Stable Video Diffusion. You can get frame control by having only the candle and surrounding objects animate. Take a portrait, AI-generated, or a photo and add a subtle animation for the hair and eyes. Or complicate things by taking your DSLR photo, for example, and creating a short video using latent noise composition. I made 6 comfy graphs, which showcase different examples of how you can fine-tune your image to video output. Let me show you my hacks and the comfy workflow explanation to get such results with Stable Video Diffusion. Firstly, I would like to thank the channel members who joined last week. We really appreciate your support. All the relevant links will be in the description. There are a total of 8 comfy graphs. The JSON files and the MP4 videos will be available to all YouTube channel members. ComfyUI supports both the Stable Video Diffusion models released by Stabality AI, and you can run it locally. I had no issues running it on a 4090. It uses 100% GPU during the K-sampler processing. I did try higher than 25 frames. The 4090 could do up to 120 FPS, beyond which it gave a memory error. However, the model is not trained for more than 25 frames, and I will stick to that throughout the tutorial. Both the models can do video at a resolution of 1024 by 576. It works both in portrait and landscape. I would say better in landscape. The first model is trained to generate 14 frames. The second model, SVDXT, is trained to generate 25 frames. I will be using this model for the tutorial. Download the model in the following folder in your ComfyUI directory. Comfy Manager is needed for the tutorial. The Manager installation has been covered several times in the past. Please refer to the Stable Diffusion playlist on the channel. Open the Comfy Manager. ComfyUI and all custom nodes must be updated. So, update before proceeding. Some custom nodes are required. Install the WAS node suite. I will use these 2 nodes in the last workflow. The Video Helper Suite and Image Resize custom nodes will be required for all workflows. After you install the nodes, close the browser and command prompt, then restart Comfy. For the custom node to work, you need to install FFmpeg. Go to the website and click on Download. Then click on Windows Builds from gan.dev. Scroll down to Release Builds. Download the FFmpeg Release Full 7-zip file. You will need WinRAR or 7-zip to extract it. I have extracted this in the same location I have Comfy. You can put it anywhere in your system. Go inside the bin folder and copy the location. From the Start menu, search for Advanced System Settings. Click on Environment Variables. Then, select Path and click on Edit. Over here, click on New and paste the location you copied earlier, then click on All Positive Options and exit. The workflow will be pretty simple in the beginning. I will keep building up the workflow and explain the settings as we progress. Ultimately, the workflow gets to a very advanced level. There would be a video model option with 1 node. Let's start with that. select the SVD checkpoint. Now add a node called Video Linear CFG Guidance. Search for SVD and add the image to Video Conditioning node. Add the K-sampler and the VAE decode node. Now, this node is the custom node called VHS Video Combine. I would use this instead of the default one called Save Animated WebP. This is because the default node only supports WebP format output. Converting WebP to MP4 is a bit of a headache. You need additional custom software to do that. This custom node allows you to export GIF, WebP, MP4, etc. within Comfy. Connect all nodes except for the image input in conditioning. I am creating a separate group for the image loader. Add the Load Image node. In Image, select Image Resize and add the node. Drag out and add a Preview node. Let's start with a candle image. This is an AI-generated image. I am choosing this one first because I want to show you how to control the motion movement and make only certain elements animate in the video, primarily the flame. Before I change the settings, let me explain why you need this node. The purpose of this node is to maintain the ratio and crop the image. You can take any image and align it precisely the way you want it. So, it does not matter if the image is square, portrait, or landscape. Change the action setting to crop to ratio. Since the max height or width can be 1024, put that value on the large side. There is no need to define the smaller side. As for the video generation, we are concerned with the max resolution not exceeding by 1024 in width or height. For now, keep the resize mode to reduce size only. The reduce size only is useful when using larger images, and increase size only is useful when using smaller images. Any does it automatically, but I prefer to set it manually. The ratio, always keep it 16:9 for landscape or 9:16 for portrait. Let's hit the Q prompt and see the preview. For this image, the crop pad position will not make much difference, but to center the image, set it to 0. Putting it to 1 will make the candle slightly towards the left. I will explain this setting further with other workflows where it really becomes useful. To use this resized and cropped image for the video output, you need to connect this node with the SVD conditioning node. I am using a random fixed seed throughout the tutorial. Steps, keep it at 20. However, the CFG value is significant and relative to the minimum CFG value set on Video Linear Guidance node. The minimum CFG value is when the video starts. The value you input in the K-sampler is the value at where the video ends, that is, throughout the 25 frames. The CFG setting is also relative to the motion bucket ID setting. Basically, the motion bucket ID and the sampler CFG will determine the camera and motion movement. The sampler and scheduler make a lot of difference in the output. I will explain this further in the tutorial. The denoise will always be at 1. But I will show you in the end where and why I will reduce the denoise. For now, you need to let it be at 1 as we need to model to add the motion animation. Reducing the denoise will just keep the image still. You have to change the height and width as per portrait or landscape. Always make sure that it's max at 1024. I do use a lower value than 576, and it works, but that is for the last workflow. Since the checkpoint model is SVDXT, I will change the video frames to 25. The augmentation level is the noise level that it adds to the generation. It is the level of detail it adds. However, be careful here as it's very sensitive, and higher values sometimes give poorer motion details than a lower value. It depends on image to image, along with the other settings. Let's cue the prompt with these settings and see what we get. Okay, there is a lot of camera movement and panning. Also, I recommend to change the frame rate to 10 from the default 8. Higher frame rates are not recommended as the total video frame is only 25. GIF supports limited colors. WebP is a way better alternative to GIF and supports 24-bit RGB with an 8-bit alpha channel. However, I would recommend going for H.264 MP4 format. It's a standard video format and can be used to upscale via third-party software. Let's regenerate selecting MP4, and you can see the quality difference. The CRF value here primarily affects when the output is in MP4. A higher value reduces the quality, and a lower value increases the quality and size. Keeping the motion bucket ID the same, a higher K-sampler CFG increases the movement of different elements within the image. Let's try a value of 3.5. Okay, so it looks like the whole flooring of the candle is moving in a different perspective than the background. And the entire movement across is slower. Let's try a value of 4.5. The movement seems to be more stable and less panning. However, reducing the CFG to 1.5 will reduce the background movement and increase the panning. Mind you, the motion bucket is still at 127. Fast panning, and because of that, there is a loss of details on the candle as well. Let's change the scheduler to simple and reduce the motion bucket value right down to 5. Now, we have a still image with only certain elements in motion, including the water reflection. This gives you a rough idea of manipulating these values to get the desired effect. Let's select a portrait image this time. This is also an AI-generated image of a woman waving. It's difficult to put motion here with the usual settings, as the whole image gets distorted. First, change the ratio to 9:16. Then, disconnect the node and Q prompt to check the cropped image alignment. Since the image is horizontal, changing values for the crop pad position will shift the image horizontally only. A value of 0.5 will center align the image. Change the scheduler to Keras and then reverse the width and height values in the conditioning. The motion bucket is set to a low value. Remember that in most images, the model is trained to detect the motion based on the image. So here, the hand will be the first thing it will add motion to. However, it's all distorted. You can now use the augmentation level to fix this distortion. Increase it to a value of 0.1. That is much better. If you want the fingers to stop moving completely, reduce the motion bucket to 1. This will just move the hand. You can further reduce the augmentation level to 0.05. This is way better. Since the animation has a cut, you can now try the ping-pong effect. This effect reverses the animation and plays it in a loop. It works for these kinds of animations. Another trick I learned is for any close-up facial image, changing the sampler to any ancestral will make the model try to animate something in the face, most likely the eyes. But for this to happen, a motion bucket level of 5 to 25 generally works, depending on the image. Let's try with 10 and see. Cool trick, ain't it? Let's explore this further in the next workflow. This workflow has a trick in which you can make the AI force specific subtle animations. To showcase this, I will be using a close-up portrait image. All images in this workflow are AI generated as well. Since this is a square image, the crop pad position value will change the cropping from top to bottom. A value of 1 will be at the bottom, and a value of 0.5 will be at the center. Note that in close-ups, all ancestral may animate the eye. However, Euler causes more motion than DPM2 or DPMPP2's ancestral. Okay, so there is no eye blinking. When this happens, try reducing the sampler CFG, bringing it closer to the minimum CFG value. Let's try at 1.1 and see what happens. Excellent, the blink is not perfect. But you can see the panning of the camera has stopped. Now, all I need to do is make the eyes blink entirely. I am going to disable this group and create a new one. We will need 2 image loaders and a set of 2 images. The same image with eyes open and one with eyes closed. This can be easily done within Painting. Search and add a repeat image batch node twice. Now add 2 image batch nodes. Now, I am going to mix and match the images. Connect the first image to image 1 of the first batch and image 2 input of the second batch. Reverse the same for the second image. Duplicate another batch image node and connect both these nodes to it. The repeat image batch has a value of 1, which goes to 2 image batches. So there would be a total of 4 images. Let me change the image. The second image is with the eyes closed. So, you can see the first image will be with eyes open, then 2 images with eyes closed, and the last image with eyes open again. This is how it should be set up for a blinking animation. You must also set up the image resize node here before connecting it to the SVD conditioning node. Let's connect and test. It worked. Let me pause here and explain some things. You need to understand why this worked. I did not use frame interpolation, which is basically adding frames. All I did was, instead of giving the AI one reference image, I gave it a set of 4 images in a specific order. I am just influencing what the AI is already doing. This method adds more pixel noise for the AI to work with. But notice how the eye color has changed. This is because there are images of closed eyelids instead of the iris in between. This messes up the color interpretation. One way to fix this is to increase the number of open eye images compared to closed eye ones. Just increasing the value to 2 will not work. Let's keep the ratio at 2:1 and increase both images accordingly. Let's increase this to 8 and the second image repeat to 4. See the difference? This is a proven method and not a random occurrence. I will show you 2 more variants of this workflow. Keeping the same settings as before, I will select another random portrait, one with eyes open and one with eyes closed. I will disable this multi-image group. First, I want to show you with precisely the same settings what the results are with just one image. There is hardly any motion here. Let's use the multi-image method and try again. "24 images will get fed into the SVD conditioning input. Absolutely nothing. Again, the behavior is dependent on the image. If you get this, you need to change the ratio so that there is more of the second image for every nth number of the first image. For this, I am increasing the repeat batch to 12 for the first image and 8 for the second. There is a blink, but with a slight distortion. If I put a 1:1 ratio, I guess it would be better. Let's try that. That is slightly better. I don't think it will get any better than this. The last thing I want to try is to see if this method works for making some facial expression, like a lip movement. Just a note here, I did try this with the same sampler and scheduler, and it did not work. However, changing to Euler Ancestral and Simple did something. That's just a tiny bit of a smile. Another thing to note is if the second image smile is too broad, you will get overlapping images. The blinking is easy and works. As I said before, depending on the image, the motion is predictable. The AI understands the image, and for this one, it should make it seem like a forward motion. However, you can get a smooth or bizarre animation, depending on the setting. Don't try to animate the pedal movement. It won't work in the current state of the model. The setting should now be clear. Increasing the motion bucket will animate the legs, head, and so on. Increasing CFG with reference to the minimum CFG will increase the camera panning and background movement. I don't want any camera panning but just a forward-moving motion. So let's try that. This is going back and forth. Oh, I forgot to turn off the ping-pong effect. Perfect. In this workflow, I want to take a motorbike example and show you the effect of having the right value of augmentation level. By right value, I mean not too high or too low. As said earlier, this setting is very sensitive, and a 0.05 or a 0.1 is a good place to start. Then, increase until you get the desired effect. Sometimes, having it a little high makes the motion lose details. This may vary from image to image, but the basic range and effect will remain standard across images. Focus here. You see how the wheel is moving. And notice the overall motion effect of the image. Let's see what happens when I change the augmentation level to 0. Everything stopped moving. That fantastic effect is not there anymore. See what happens when I increase it to 0.4. There is more smoke, but the most obvious movement of the front wheel is motionless. This workflow is a complicated one. I would generate 2 videos and combine the effects. I will use a technique called noisy latent composition. This is a DSLR photo taken by my colleague with his Fuji. I want to move the waves slowly and add clouds in the sky with a time-lapsed motion effect. Nice and smooth. Let's create a group for the second video. I am going to use image to video again. However, you can use text to image or a ready-made video. This is a cloud image I have generated using Photoshop Generative Fill. Any image of the cloud would do here. And don't worry about the ratio or dimensions of the image. I will turn off this group while I work on the other image. I am going to add a node called Image Size to Number. This will show me the resolution after cropping within Comfy itself. I will need that as the second video cannot be the same height as the first video. I need the second video to fill the sky. Now, I will add 2 number to text nodes and connect the width and height. The Show Text nodes will display the width and the height. After cropping, the image size is 704 by 396. Replicate the entire video processing group for the second video. Connect the image to the second SVD conditioning. The height cannot be 576, as it will replace the first video. As the resize height of the second image is 396, we need the height to approximate that value. 392 is good enough, as it can be either this or 400. This will do. This group is important, as all the prompts and the output from the K-samplers will be combined here. For the prompts, I will use conditioning combine nodes, 2 of them. The order of the positive and negative does not matter, as I am going to use a latent composition node. The order in that node will matter. Connect the positive to the first node and the negative to the second combine conditioning node, from both the SVD conditioning nodes. Add a latent composite node. Here, the second K-sampler will connect to the samples from input. The first K-sampler will connect to the samples to input. This node copies the samples from and pastes it on top of the samples to. I want the clouds to be pasted over the main boat image. So remember this order for the latent composite. Add the third K-sampler and connect the model from any one of the CFG guidance node. Connect the conditioning combine and the latent composite nodes with the K-sampler. Here the denoise value should not be 1. In the previous two samplers, we put 1 because motion has to be added in addition to the pixel noise in latent space. We already have the pixel output now, and we don't need to change much of the video outputs except blending it. Hence the noise here should be 0.2 to 0.3. This will ensure that the output from the third case sampler is relatively very close to the first two, just combined. Add the VAE decode and connect it to the final video output. Keep the feather value at 0 at first to see how it combines. We can then alter the value accordingly to blend it. We can try changing the feather value to about 256 and see what happens. Beautiful. This is the entire workflow to get this output. The only thing remaining is the text-to-image group, which will connect to the video processing group. You add a standard text-to-image workflow. Ensure the height and the width are near 16:9 or 9:16 ratios, whatever works best with the selected checkpoint. Connect the VAE decode node to the image resize node. This will connect to the SVD conditioning. And that's about it. All JSON files will be available separately for YouTube members. I hope you found this tutorial helpful. Until next time.